So let's I open the NX as usual, the new file, the model, press OK. From this week we have to start here the feature group elements. So far we have seen the extrude with the revolve function, and we have seen the edge blend, chamfer, and how to make the mirror here, the mirror the feature. So today we will see the how called design the features. So mean create the feature without any sketches. Here the hole, there is the several type of the hole is exist. Also if you open from the menu, and here we insert, and you see here is the group, call it the design feature groups, is the extrude, revolve we have seen. And today we will see the how to create the block, cylinder, cone, and sphere, as well as the hole. So, and upcoming lectures and upcoming labs, we will see the other here the design feature. And the curves, the sketch curve, we have seen all the sketch curves here, and so on. Let's start with the design feature. Let's start with the block. Block is the rectangle. So you see here in the type, you see there is several. I mean in the general three type of the block you can create. Just a moment. So you can create three type of the hole. Firstly, you can create a block with the origin and the edge length. Let's select this one. In this case, so you see specify the origin. You have to specify any origin. For example, here it is by default is the creating this one, and you see here the sizes of the block. Here the 200, the length, width, and height. So if you press OK, you see the block is created with the double click here with this side, the length, width, and height. So press OK. You see how to create the block directly without any sketch. So this is the call of the design features. Also here, if you open the more, you see here the block cylinder design features is located here, the cylinder and so on. I can use this one with the opening the more, or you can use here the menu, insert, and the design feature. So it is the related to you how to use this one. Just a moment. So next see the another method how to create the block. Open the block here with the 2 points and the height. So you have to specify the firstly point. For example, this point, you see I specified the point, and you have to specify the point with the point, second point. For example, this point, you see I specified the point, and there is the you can change the height, for example 50, and press OK. Most important is to select the 2 points, first point and second point. So you see with the block is created with the second method. Next method is of the block. Let's see with the 2 diagonal points. So this is the first point which I selected, and as a second point you can open here the point dialog, and make the for example select this point and make the height, it should be the greater than 0, for example 100, and press enter and press OK. OK again. So the block is created with these 2 points, and with the height is the 100 millimeter. So this is the how to obtain the blocks with the 3 methods. So you can use any of them according to your wishes and so on. So next is let's make with the cylinder. In the cylinder you have two options, with the axis diameter and height, or with the arc. Let's see the first option. In this case you have to here select the vector of the cylinder, for example z-axis vector, and let's specify here the point, for example this point. You see the cylinder will be created along this line. So here you have to specify the diameter, the dimension of the cylinder. For example, let's make it 100, 200, and the height is the 120. Okay, press OK. You see the cylinder is created with this method. Also, for example, in the cylinder with this method, with the first method, you can specify the vector. For example, this vector or this vector, and according to this one, the orientation of the cylinder will be the different. For example, the point, select the point and press OK. You see orientation along this axis. Also, you can create the cylinder orientation along the x-axis. Now here is a z and y-axis and so on. It is the how to create the cylinder with this method. So in order to create the cylinder with the second method, we need the sketch arc. We need the arc. So let's sketch the arc. Press the sketch. For example, press this plane. Press OK. And let's here draw the arc, any arc with any dimension. So press the finish. So we created the arc here. So using this arc, so I would like to create the cylinder. In order to do this, I go to the more or select the cylinder, and here I changed my tab, here the arc and the height here, and here you see that you have to select the arc. So this arc I selected, and height is let's keep it 100. Also you can change the direction by here, it's a reverse direction from the upper or downward direction. So and press OK. You see the cylinder is created with the using just the arc. So this is the how to create the cylinder with the two methods. And the next method, design feature, let's see the cone. For example, in the cone we have the several options. So around 5 options. The simple one is with the diameter and the height. And if you select the type of the diameter and the height, you will obtain this kind of the window. So you have to first specify the vector. For example, let's make it z axis, and specify the point. For example, this point. And here the dimensions of the cone. For example, the base dimension is this is the base dimension. So let's make it 300. And this is the top diameter. So let's make it 0. And this is the height of the cone. Let's press OK. You see the cone is created with these three the parameter. For example, if you make it for example 100, the top diameter, it will be changed to the 100. You see it will be not become the not sharp edge. So it is the how to create the cone with the diameters, upper and lower diameter, and with the height. There is also other methods of the cone, creating the cone. You see here the several options with the diameter and the half diameter. Then you can use, for example, this one. Always you have to indicate the vector here, that vector, the point, for example, this point, and here the dimensions, base diameter, top diameter, and let's make a half diameter is the 50. It's okay. You see the cone is created with these parameters. So just a moment, and let's see the other options for the cone. Base, height, and half diameter is almost the same here, and this is the same. So this is the same. Almost you have to indicate the dimension, and here we have to create the two arcs. So in order to create the cone, for example, let's sketch. Let's select this plane. Press OK. Okay, let's draw the one arc here. Just a moment. Okay, so finish the sketch. So arc is created. Now create the second arc. In order to do this, let's create firstly the plane. This plane at a distance of is okay. So sketch. Select this plane. Press OK. So create the arc here, near here with For example, we can create with a smaller arc. Finish this case. So we create the two arcs here, you see, and using these two arcs, I would like to create the cone. Is the go to the more cone here, go to the coaxial two axis, two coaxial arcs. So select this arc. At the second arc, select this arc, and reverse the direction. So I think it's okay. Let's see here. Arc is created based on the two arcs. I mean the cone is created. Sorry. So this is the third object. Is the design feature. The last one, which we have seen as a design feature, is the sphere. It's the sphere. We have two options: create sphere by the center point or diameter, or with the using the of arc. So use the first option, center point, and then let's define the center point. For example, center point is here. You see, it is selected. You can select any point like this, and then let's make the diameter of the cone 300. Press OK. The cone is created. So this is the simplest way. The second way of the creating hole, we need also the again the arc. Let's draw the arc with any dimension. Sorry, just it's okay. Finish the sketch. So arc is created. Go to the more, select the sphere, change the type to the arc, and here you see you have to select the arc. So select this one and just press OK. So you see the cone is created. So radius of the cone will be the radius of the arc, so it will be equal. So I didn't define it, but the radius exactly will be the radius of the cone. So this is the how to create the design features like the block, cylinder, cone, and the sphere. So you can find the design features from the here menu, insert, design features. So we have seen the extrude revolve. Now we have seen the block, cylinder, cone, and sphere. Now let's see the function. See the function of the hole. So in order to do this, I will open the new file. It is the better. So model, press OK. So to go with the hole, also you can find the hole feature here directly in the ribbon bar. So from the home and the ribbon bar, you see. So in order to do this, I will firstly create the block for the hole. Let's make it the origin, and let's this origin. So press OK. So I create the block. Let's make it more the longer. So let's make 300. Press OK. So I created my hole. In order to create the hole, firstly, it is the better to define the point for the hole. So in order to do this, I will make the sketch and select this face. I want to create the hole on this face and press OK. I want to define the point for the hole. So in order to do this, I will use here the point curve. So I will press here. You see, point is created. Close it, and you can define the dimensions of this hole like this here by the double clicking here. Let's make it 30 from this side, and let's make it again 30 from this side, and finish this. You see, hole is the point that is for the hole is created. We have another method to create the point for the hole. We will see this step by step. This is just one method. Now I will go to the hole feature. Select the hole feature. So if you open here the type, there is, you see, several type of the holes. It's the general hole, the screw holes, the drilled holes, and the threaded, and the hole series. Let's see all of them step by step, starting from the general hole. So in the general hole, if you open here, you see here firstly you have several form of the holes. It's the simple hole, counterboard, and countersunk, and tapered holes. So let's see with the simple hole. And here in the position you have to select the position for the hole. In this case, I will define as this position, that point which I predefined here. This point, you see, I select here this point. You see, hole is creating. The simple hole is creating with this dimensions, with the diameter 7, depth is this one, and the tip angle is this one. And also you have to be careful that here boolean always should be the subtract, since we are creating the hole. So we can change the values here. For example, let's make it the diameter is 10. This is a simple hole, 10, and we can change the diameter, for example, the 50. Or also you see here you can define the dimensions like this or until the end and so on. It depends on you and your sketch. You see, hole is created. Let's make it smaller because it is the making the hole here. So this is the how here general hole, and the type of the form is a simple hole is obtained, and press OK exactly on the dead position. So we can see from the view edit section and select this section, and you can drag here to see our the whole shape. This is the simple hole. Here we have the tip angle with the depth of the 45 and the diameter of the 10 is created. This is the how the hole is created. That is the simple hole. Okay, let's go on with another type of the holes. Select the hole and the general hole. Let's see here the second form is the counterboard hole, and the counterboard hole, you see that several parameters is created different from the simple hole. And also, as I said before, there is the direct method that in order to define the position of the hole exactly in the hole feature, so not to use the previous one. So we can define the position of the hole. For example, select any point here. You see, it is created the whole point, and close it, and we can define the dimensions from here to from this side. So it was the 30 from this side. Let's make it the same, and let's make this dimension. Okay, let's make 50 from this side. It's too close. Let's make 60. So this is the position of my hole here. If we here press the finish, hole creates automatically, demonstrates. Let's wait. You see, counterboard hole is created here with these dimensions. We can change the dimensions. For example, let's make the depth as similar as the previous one, 45. And you can make here the bore diameter is this the upper diameter. For example, let's see the result how it will be, and this is the depth for the bore, and this is the diameter of this diameter. So if you press OK, you see the hole is created like here. Let's make this bore diameter is the smaller, 20. Press OK. So we can also see the result with the cross section. So let's see here. You see here the counterboard hole, how it's obtained. This one. This is the cross section of the counterboard hole. Cancel. So this is the second type. So let's go to the home, select the hole again, and still we are in the general hole. We will see the other step by step. Now we will see the third type of the form is the countersunk. So for the countersunk we have obtained these parameters. The same way we have to specify the point. For example, this face, you can specify this face and other face. So close it, and let's define the positions as usual. Firstly, let's make it for example 80. It's close to, let's make 90, so it's okay. And this distance was the 30 millimeter from this side. Okay, finish. So countersunk hole will be created with the default parameter. So you see here with this one. So this is the countersunk diameter, first one. So let's see what is this parameter. If you make it 30, so you see it will be greater. Let's keep it 20. This is the third one, is the angle of the countersunk, this angle. So let's keep it 90. The diameter is 10 and the depth, let's make it 45 as the previous one. So the tip angle, as we've seen in the lecture, so it is the most cases will be the 118, and the boolean is always subtract. Press OK. So again, view, checked our results from the Z. So from the Y. So let's move it. So this is the third type of the form of the simple hole. Cancel. Again, go home and again go the hole. So general hole. Last type is the tapered. So for the tapered we have the less parameters here. As usual, specify the point. This face, for example, you can select any face as you want. Close for a while this one, and let's define the dimensions of this point. So it is the 30, and along this sorry along this axis, let's make it 110. Okay, 120 is okay. Press OK and finish. To obtain the hole. You see, tapered hole is created, and let's make the depth is 45, and here the diameter and taper angle you can define as you want. Diameter is this is the upper diameter, so press OK. Let's see the result as usual. View, here and along the y-axis. So from this side. This is the types of the simple hole type with the form of the 4 different forms of this one. The same way that we will go to the next hole type is drill size hole. In this case, there is only one form. One form is just the drill size. So the same way we have to define the point, almost the same. So this point, and let's define the coordinate position from this side. Let's make 130, and from this side, this side is the same, 30 millimeter. Finish the sketch. Drilled hole is creating, but it is now too small. You see here, here we have the size, standard size we have for the drilled, so we can choose any standard size. You see, and you can choose any standard size. For example, let it make bigger here. You see, for the drilled size, and you can define the depth, measurement point, and the tip angle, and so on. You see, for the drilled size hole, where is the standard values? You can so many. So this is the how the drill size is obtained, and press OK. Unfortunately, for the drilling is not demonstrable, so it is just a hole. So this is the how to obtain this one. Okay, let's go on. Next is the screw clearance hole. So in this case, see, we have also the three form of the screwed hole: simple, counterboard, and countersunk. Let's see the simple one firstly, and we have here the several standards for the screw. So it is the M12 and so on. You can define according to your the screw hole. So firstly, you have to define as usual the position here. So select the face here and close it, and define these dimensions. It was the as usual 30 millimeter, and define this dimension from this side. Let's make it 100, and you see hole is created on this position. Finish it. You see the screw hole with the simple is created. So let's make it depth is the 45, and you can change it here the values, for example M16 bigger, and 22, and 12, and so on. So this is the how it's obtained. So taper angle and the distance you can measure from this side or this side. It depends on your project. So you can define any length. That's okay. Again, open the hole. So let's make it countersunk and counterboard. The same standards. So the same standard here. It is the not changeable standard. So specify the point. The same here. Also, when you locate this point, you can use the geometric constraints. For example, press C from the keyboard, and you can make it horizontal. So this point with this center point, you see it will become the horizontal. For the defining this dimension, so you can define this horizontal constraint. Now we will define this dimension. Let's make it 60. So close it, finish. So this is the counterboard hole is created using the screw thread. So screw clearance hole. So with the you see with this dimension, depth is the 45, and the tip angle is this one. Also here we have the standard M12. We use it M12 screw, standard screw user. So you can use the M16 and so on. Let's make it M12. That's okay. You see the several type of the hole step by step, and the next step the same screw hole, and now countersunk. So standard, several standards, and the depths and the tip angle. You can define the depth and tip angle. Since the standard we choose it here, there is the fixed values for these three parameters. So let's try the point again. So you can use again constraint. So horizontal constraint this point with this one. So next define this. Also you can use the rapid dimension, define this point, this one, and this one. Let's make it 30. So finish it. So countersunk is created. You see with the depth is this one, and also with the standard of this one. It is the same. Since we are using the standard, you are not able to change these values, and press OK. Let's see the results with the cross section, with the intersection. So you see the holes, several type of the holes. According to your project, you can use any of them. It is not all. We have other the hole types again. So let's see and make the clearance between the holes. Select the hole again from the home tab. Next is the threaded hole. The same, you have standard for the threaded hole, several the standards, so you have to learn the standards as well. Let's make 12, and the same way you have to indicate the position for the hole here, and let's keep it like this. Finish the sketch. See, the standard hole is created. You can define here the depth 45, and here the several parameters you can define, this one, taper angle, and so on. Press OK. So standard hole is created here. So last type of the hole is the let's go to the hole. It's this one, hole series. In order to do the whole series, I will draw the another sketch, another rectangle. For example, let I draw here the rectangle with any dimension. I would like to extrude it. So, okay, I will draw the datum plane. For example, let's make it smaller. Let's make it 2 datum planes with a distance of the 210. We will see next week how to create that kind of datum planes. So it is the important such kind of datum planes create. Now I would like to draw another rectangle on this datum plane. Select this one, press OK. So rectangle, let it bigger, and directly extrude it. So it is OK. Now I would like to draw another rectangle on the third plane. Press OK. Any rectangle. Dimension is not so important now. Just press OK. Now series hole is represents us to create the holes directly that passing through the three solid elements. So let's see. Press hole. So go to the hole series and select, for example, this face, the position. You see the position is defined. You can, as usual, define the position of this hole. For example, let's make it 70, or you can make using a geometric constraint, for example, midpoint. This point is the midpoint of this line, so it will become directly in the midpoint. And finish the sketch. You see, whole series create the holes. So along these lines, along the existing, if I increase my solid elements, rectangles, it will be increase the hole. So it automatically just makes the whole series. For example, this is the start element, here in the mid element, you see, and this is the end. So this is how the whole series is created. And if you say, for example, the form here is threaded, you see there is the several form can be obtained. This is the end, this is the mid, and this is the start point. So you see, for the start point you can make different values. For the midpoint and end point you can customize the different values with you see the different depths. For example, you can change the depth. For example, here let's make it 10. It's the end value. You see it will be and here. The same way you can change the start values. For example, the standard values, all the values will be changed holes. And the type of you can select. For example, if you select the counterboard, only start will be the counterboard, others will be just the holes. You see, it is the simple hole. If you countersunk, start will be the countersunk. That's how to create the hole. Here is this is the all the holes or the type of the holes you can do by yourself to practice to create the holes like this, and it is very useful. So is it clear the features for the today, just the topics? If that is clear, let's make the practice with the revolve function. So let me open the practice for today. Saying that this one, yes, let's do this one. That's revolve. Okay, I will open my NX. Let's open the new file. So okay, as usual, in the revolve function, which I explained it in the theory, so we have to always focus on the cross section and revolve around the axis of this cross section. In this case, we will focus firstly our attention to this cross section and revolve it around this center axis in order to obtain this element. So let's go on. So sketch. So let's select this plane, press OK. Let's draw the first this line. So let's make it symmetric. This line, this point and this point. Okay, let's define firstly the dimension. Dimension of this is here, say 50 millimeter. So rapid dimension, this is the 50. So and the distance between the, let's define this one and this one, let's make it 0 in order to make the symmetric, so it locates directly on the middle. So and now let's draw this part. So using the profile, we can use the profile because it is the chain of the lines like this. Let's see it. So we will go here, here, so now we finished the sketch. Let's define the dimensions. Firstly, the dimension is here is the 30, since from the center it will be the radius 15. So rapid dimension, distance from here to here is the 15, and the next dimension let's define, this is the 40. So distance from the center to the this point, I mean this point is the 20, the half of the diameter. So distance from here to here is the 20, half of the 40. So next is the so we defined this one, and so next is this diameter is the let's define firstly this one, this one is the half of this 104. With dimension, this distance is the 104 divided by 2, and the total length is this one, not this one, but I mean this one is the 70, distance between this one and this one is the 70 millimeter, half of the 140. So we can change this value like this, So and let's define these dimensions. This is the 17, 5 and 1.6. So let's firstly define this, so it's correct, and this distance is the 5. So and this distance is 1.6, and let's define the angle between this one and this one is the 34. And let's define the dimension between the vertical dimension this point and this point is the 17. So let's make it movement. No, okay, let's go back. So okay, now let's define the another dimensions. Distance between this point with the midpoint of this one is 13.5. So let's define again this angle 54. Now it's correct. Make it parallel this line, so parallel this one with this one. Now let's go back. So let's define this dimension. No, so we can define the dimension. For example, let's make this dimension 5. And let's make this dimension we have remained, this one and this one is the 60. No. So this is almost finished. We can make the mirror. So let's make it a mirror. Here the select the single curve. So let's make a mirror this one, this one, this one. Select step by step all of them. No, let's make it not the mirror but the pattern. So we can use also the pattern in the case of the general single curve. So we can start from here, here, here. as a start point, select this point and specify the point is this one. You see, you obtain this one. Press OK. Now we can define the other dimensions now. So distance is 23 here. So distance from center point so to the mistake. So can create here the line till the intersection and let's delete this one and let's define the distance from here to here is 25. It's okay. Let's okay, and also this distance. It's okay. Also the 25. We can extend this line till here. Delete this line and let's make equal lengths. So it will become equal lengths. Sorry, it is this is a mistake. There should be the mirror after this line. So mirror. Here let's select a single curve. This one, this one, this one, and as a center line select this one. So it is the mirror, you see. Press OK. So it is the finished. Sorry, I think that there is a mistake here. Just a moment. Okay. No, it's correct. We defined it. So say it's correct. Can go to the Revolve, select the curve, and as I select the vector, this vector, and point is this one, we can go here, dialog, and here the select here the select cursor location, and here you see center point 0 point is created. So just a moment. There is the maybe open system here in the here the open system. Let's correct it. Yeah, you see here is we have to trim it. That's the trim it and close. Go to the Revolve. Now it's okay. Specify the vector, this vector, point. So point cursor. Okay, that's the center point 0 point. Press OK. Now you see Revolve function is obtained and now press OK. This is the how to make the Revolve function with this element. Oh, you can hide this one. So this is the how to obtain the Revolve. So we can finish at that time. Okay, if everything clear, what I want to inform that tomorrow, if you agree, just I want to shift the tomorrow lesson for the Saturday, okay? Because I have the conference for tomorrow and exact at it start at 3 o'clock, something like this, at 2 o'clock, I don't know. So in this case, I would like to shift the tomorrow lesson on the Saturday, okay? I will anyway inform it in the channel. So, but I would like to just now to inform that tomorrow our the lesson will be postponed to the Saturday. Is it okay for you? Because I have the conference